Hi guys, so I'm going to make a review video on the Unit 5 review. Okay, so let's get started with circumference, area, and similarity. Okay, so here we're going to find the circumference and area of the circle. Just a reminder, circumference formula is pi times diameter, or if you're given the radius, diameter is 2 of our radiuses, so we can also do it as 2 pi r. Okay. The area formula is pi r squared. So those are the formulas we need. Okay, so here in the circle, I am given the diameter. This is d here. So if I was finding the circumference, it'd be pi times diameter, which is 30 feet. Okay. So circumference is 30 pi feet. That's the exact answer in terms of pi. And then it is approximately 94.248 feet. Okay, so that's the circumference. Okay. Area is pi r squared. So if my diameter is 30, my radius is half of that. So that means radius would be 15. So area is pi r squared. So area is pi 15 feet, and I'm squaring that. Okay. 15 squared is 225. So 225 pi. And then feet times feet would be feet squared here. So that is my exact answer. And that is approximately 706.858 feet square. And that is my approximate answer. So next one here, radius here is 5 centimeters. So circumference is 2 pi r. So 2 pi, radius is 5 centimeters. 2 times 5 is 10. So 10 pi centimeters. That is my exact answer, which is approximately 31.416 centimeters. Area is pi r squared, so pi, radius is 5, so 5 centimeters, and I'm squaring that. 5 squared is 25, so 25 pi, and then centimeters times centimeters is centimeters squared. That is my exact area, and that is approximately 78.5. It's 398, so it's going to round up to 540. There's circumference and area. Okay. So next question here. I'm told that the circumference is 16 pi inches. So circumference is 2 pi r. So 2 pi r, my circumference formula. We know circumference is 16 pi, so equals 16 pi. Okay, inches. I'm going to solve for r in order to find the area of the circle. So since this is multiplying, I get rid of it by dividing. Okay. So these cancel, leaving me with r equals pi and pi. 16 divided by 2 is 8, so radius is 8 inches. Then area of the circle is pi r squared, so a equals pi. Radius is 8, so 8 inches, and I'm squaring it. 8 squared is 64, so 64 pi. And then inches times inches is inches squared. And so here is my answer. It wants it in simplified radical form. There is no radical. It wants it in terms of pi. Here it is. Okay. And here's the next one. Okay. Area of a circle. This time, instead of circumference formula, it gives me area. So area formula is pi r squared. So area pi r squared equals 75. And then this is pi and then miles squared. Okay. Solving for r in order to find circumference, so divide by pi, because it's multiplying. Okay. This cancels out, leaving me with r squared equals 75 miles squared. Okay. I'm going to get rid of the square by square rooting both sides. So this leaves me with r. Square root of 75, if I do the tree, it is 5 square root of 3. And then miles squared and the square canceled, leaving me with just miles. Okay, so this is my radius. Now, to find my circumference, circumference is 2 pi r. So 2 pi, and then my radius is 5 square root of 3 miles. Okay. Then multiplying everything outside a radical, so 2 times 5 times pi, so that's 10. Okay. Square root of 3, and then pi afterwards, and miles. Okay. And this is my answer. It's in simplified radical form and in terms of pi. Okay, next here is find the translation rule and the scale factor of the dilation. Okay, so first, originally xy, okay, and then see how it translates. So this is the pre-image. How do I know? Because A. This is the image because of A prime. Okay. So it moves from using the center to help me find how it moves. It goes 1, 2, 3, 4, 5, 6, 7 to the right. Oops. So that means with x it will be plus 7. Okay. Then it moves up 1, 2, 3, 4, 5 up. So that's dealing with y's. Up is positive, so y plus 5. Okay. So that's the translation rule. Okay. Scale factor here relates to our radius. Okay, scale factor is image over pre-image. So K for scale factor. Here, radius is 1. This one here, radius is 3. So image over pre-image. So 1 over 3 is the scale factor. Okay. Then next one here. Okay, so B here is again pre. This is the image. Okay. So let's see how it translates, how it moves left and right. So xy originally, what happens? Using the center to figure out how it moves to the right 1, 2, 3. So right is positive, so that's with x plus 3. And then it went up 1, 2, 3, 4, 5 also, so up 5. So y plus 5. Okay. If it was left, it would be minus for x. If it moved down, it'd be minus for y. Okay. Then, figuring out my radius, this one is 1, 2, 3, 4, 5. This is a radius of 5. This is 1, 2, 3, 4, 5, 6. Radius of 6 here. So scale factor, image over pre-image, 5 over 6. And there you go. Next one here. Okay. So this time I want to say, are they similar? First of all circles are similar because they relate to our transformations. Okay, so is circle A with center blah 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 radius similar to? Yes. So they are similar because all circles are similar. They can be mapped on top of each other through transformations. So how do they map onto each other? If circle A, okay, so let's figure out how it moves. Right. So taking the x's here, so 4 minus negative 3. Minus a negative is plus, so that means 4 plus 3, so 7. So here it means that it moved right 7, because I did that with the x's. Okay, and it's positive, so that means right. So if circle A was translated 7 right, okay. And then let's see how the y's move. So this is negative 9 and this is 5. So negative 9 minus 5 is negative 14. So it's negative and this was y, so that means it's down 14. So if circle A was translated 7 units to the right and 14 units down, okay, and then dilated by a scale factor. Okay. Image over pre-image. So since I'm talking about how circle A moves to circle B, so radius 6, radius 1, so 6 over 1, or 6, okay, around its origin. So all circles are similar because they trace back to our two transformations of a translation and a dilation. Okay? Through these translation and dilation, they map onto each other, making them on top, making them congruent, and because of that, they are similar. Okay? So here's the next one. So circle A, center 110, radius 4. Similar to circle B, center -2, -7, radius 2. Explain. So again, they're similar because all circles are similar, because they can be mapped onto each other after a transformation. So I'm going to explain how these circles are similar. Okay? So using the x's to figure out how they move left and right. So -2 minus the 1 here is -3. So that means it moved this way 3, left 3 towards negative numbers. Okay. Then using the y's to figure out up and down. So -7 minus the 10 is -17. Moved down 17. Okay. And then for my scale factor, it is image over pre-image, so 2 over 4, 1/2. Okay. So they are similar because all circles are similar. Right. They relate back to my two transformations. So they can be mapped onto each other if circle A was translated 3 units left and 17 units down, and then dilated by a scale factor of 1/2 around its center. There you go. Okay. So so that's all of 5A. Now we're on 5B. It relates to all of those rules that we know. You do need to have them memorized or written on your card. Okay. So here is AB. So AB is here. Is it tangent to circle C? Okay. So tangent lines should be perpendicular to our radius at the tangent point. Okay. So here, if these were tangent, they should be perpendicular, and that's what we're testing. Okay, so here, if it was perpendicular, it would make a right triangle, meaning Pythagorean theorem would work for it. So let's see. Okay, so a squared plus b squared, so 3 squared plus 4 squared, does it equal 5 squared? Let's see. 3 squared is 9, 4 squared is 16, 5 squared is 25. 9 plus 16 is 25. Does 25 equal 25? Yes, it is. So that means AB is tangent to circle C. Okay. So let's see about this one. Okay. So here, again, is AB tangent to circle C? If it is, it should be perpendicular to this radius. We're here to test that out. Okay. So this is 12, this is 5. So 5 squared plus 12 squared equals, this 8 is talking about this section. So what is C to here? C to here is a radius. So if this radius is 5, this would be 5 too, making this a total of 13. Okay. So let's see. 5 squared is 25. 12 squared is 144. 13 squared is 169. Okay. 25 plus 144 is 169. Does 169 equal 169? Yes, it does. So that means AB is tangent to circle C. If it isn't equal to each other, that means the Pythagorean theorem didn't work for this, which means that they are not perpendicular, which means that it would not be tangent. Okay. So here we go for the next part. We're going to find x and y and all of our variables. And so let's get started. So here, I see that this is 134, this is 152. Okay. So in order to find this central angle and this inscribed angle, I need to know what this arc is. Since I know this piece, and together it forms a circle, should be 360. Okay, 134 plus 152. Okay, subtract that from 360 is 74. So this arc here has to be 74 degrees in order for this whole circle to be 360. Right? So 134 plus 152 plus the 74 equals 360. Okay? So x is also 74 degrees. Okay, or 74. Okay. The reason why is because this is a central angle. Central angle is equal to the arc. Okay. Y here would be half of my arc. Okay. The reason why is because this is an inscribed angle. Inscribed angles are half of the arc. So half of 74, 37. So y is 37 here. Okay. On to the next one. So this one is a tangent line. We're going to assume that it is based on how it looks. Okay. So here, that means this would be perpendicular, okay, which means that Pythagorean theorem would work for it. So that means x squared plus 4 squared equals this together. If this is 3 and this is x, it should be x plus 3 equals x plus 3 squared. Okay. 4 squared is 16. X plus 3 squared is x plus 3 times x plus 3. It is not x squared plus 9. How I know is because when I distribute this, x times x is x squared. X times 3 is 3x. 3 times x is 3x. And 3 times 3 is 9. Okay. If you just distribute it, you would be missing these 3 x's here. Okay. So this is x squared plus 6x plus 9. Okay. What I'm going to do is I'm going to move the x squares to the same side. So subtract x squared. Happens to cancel out, leaving me with 16 equals 6x plus 9. Okay, I'm going to slowly isolate x, so get rid of the plus 9 by subtracting 9. This is 7 equals 6x. And then get rid of this times 6 by dividing by 6. So 7 6 equals x. If you want, you can change it to a mixed number to be 1 and a 6. Okay, next one here. Okay, here I have congruent chords. How do I know this is 6 units long, this is 6 units long? Okay, congruent chords are equidistant, okay, to our center. And so that means 5x minus 2 equals 3x plus 4. Okay. Going to move the x's to the same side, so subtract 3x, subtract 3x. This is 2x minus 2 equals 4. Okay. Going to get rid of the minus 2 by adding 2. Okay. So that means 2x equals 6. And then get rid of the times 2 by dividing by 2. This will be x equals 3. Then the next one here. Okay. So again, I have congruent chords. Okay. Congruent chords have congruent arcs. So if these chords are congruent, this arc 130 should be the same as this arc 130 degrees. Okay. This angle here is formed by tangent and a chord, okay, which that means this should be half of the arc. So that means x is half of 130. Okay. Which means that x is 65. Okay. Then how would I find out what this y is? So a circle all the way around, the arc should measure to be 360 degrees. So here, 130 plus the 64 plus 130 plus y should give me 360. Okay. So 130 plus 64 plus 130 is 324. So 324 plus y equals 360. If I subtract 324, both sides, y equals 36. There we go. So next problem here. Okay. So these are lines. They intersect outside of it. So this is outside times whole equals outside times whole. So here, outside section is 9 times the whole thing. If this is 9 and this is 11, the whole thing is 20. So outside times whole is 20 equals, outside section here is 10 times the whole thing. That would make this 10 plus x. 9 times 20 is 180. 10 times 10 is 100. 10 times x is 10x. Then subtract 100 on both sides. That would give me 80 equals 10x. Get rid of the times 10 by dividing by 10. So 8 equals x. Okay. The next one here deals with angle measures inside of my circle. Okay. So first, I would need to know what this is in order to find x. Okay. So together, these are a linear pair. So if I do 180 minus 118, that will give me what that is. So that's 62. So this here is 62 degrees. Okay. And so when we have chords intersecting inside of our circle here, okay, this angle that it forms, this 62, will be half of the two arcs added. So x plus 80. Okay. Opposite of multiplying by half is multiplying by 2. So this will be 124 equals, this cancels, leaving me with x plus 80. Subtract 80 on both sides. And this will give me 44 equals x. There we go. Okay. Next one here. Okay, I have two tangent lines. They intersect outside of my circle. Tangent lines, when they intersect outside of the circle, those tangent segments are congruent. So what that means is 2k squared plus 3k equals 14. Okay. This is a quadratic. No way to get rid of that k squared. So I'm going to solve by solving a quadratic. I'm going to choose to factor it. Okay. So I'm going to subtract 14 on both sides. Okay. This gives me 2k squared plus 3k minus 14 equals 0. You can choose to either, I wouldn't complete the square, it's a little too complicated for this one. You can do quadratic formula if you want, or factor. I'm going to factor. Okay. So if I factored it, it'd be 2k plus 7 times k minus 2 equals 0. Okay. How I can check it, right? 2k times the k will give me 2k squared. The 7 times the negative 2 will give me the negative 14. And if I do 7k minus the 4k, that comes from 2k minus, that'll give me the 3k. Okay. Then, set each equal to 0. So 2k plus 7 equals 0. K minus 2 equals 0. When I solve it, this gives me negative 7 halves. This one gives me 2. Okay. If I plugged it back in, okay, 2 times negative 49 over 4 plus 3 times -7 x. Okay, this gives me a negative answer when I plug it back in, so I just want the positive one. Okay. Then here's the next one here. For this one, I have inscribed quadrilaterals. Opposite angles are supplementary. So 7y minus 16 plus 4y minus 2 equals 180. 7y plus 4y is 11y. Negative 16 minus 2 is negative 18. Add 18 on both sides to slowly get y by itself. So 11y equals 198. 198 divided by 11. So since this is times, opposite is to divide. Okay. So here, y equals 18. Right. Then same thing, opposite angles of an inscribed quadrilateral are supplementary. So 4x plus 5x equals 180. 4x plus 5x is 9x. 9x is 9 times x, so get rid of the times 9 by dividing by 9. And x equals 20. There you go. Okay. So that's 5B. A lot of memorization for that. Right, so I would probably put pictures on it to help, and examples, rules, things like that, because 5B is the one with the most memorization. Okay. So 5C is equation of a circle. Okay. So reminder about equation of a circle. This is the equation, x minus h squared plus y minus k squared equals r squared. H and k make the center. Okay. And then r is the radius. Right? So all you need to write the equation is knowing the center, hk, and the radius. Okay. So here, the center of the circle, kind of find the middle part, right? It should be equidistant on each side. So here's my center. The center is at 3, 5. This is h. This is k. Okay. Radius here, 1, 2, 3, 4, 5. So here, radius is 5. Okay. It's the same, right? Center should be the same every way. So here, 1, 2, 3, right? So it's 5 either way. So radius is 5. So writing my equation, x minus h, so x minus 3, then square, plus y minus k is 5, and then square, equals my radius, which is 5 squared. Okay. I'm just going to simplify that 5 square here, which is 25. And here's my answer. Okay. Next one here, I'm going to find the center of the circle. It should be in the middle, so here it is. Okay. This is negative 3, 0. Okay. Radius here is 3. So I'm going to plug it in. So x minus h, so again, hk. So x minus h is negative 3, and then square, plus y minus k, which is 0, and then square, equals my radius, which is 3, and then square. Okay. Minus a negative is plus, so x plus 3 squared. Y minus 0 is just y, so y squared, and then 3 squared is 9. And there you go. Okay. Next one here. Okay, I am graphing the circle. So here's my equation. All I need is the center and the radius. So here, x minus 1 squared, y plus 2 squared. So center is at 1, negative 2. Right? Sometimes we think of it as opposite signs. Since it's x minus h would be 1. Since y minus k here, this is really y minus a negative 2. It just simplified the minus negative to a plus. So if it's y minus k, k is negative 2. Okay. This here is r squared. Okay, so if r squared is 49, that means the radius is 7. Okay, so center at 1, negative 2. It is. Okay. Then I'm going to count 7 in each direction. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And then 1, 2, 3, 4, 5, 6, 7. Okay. And then you just connect it. For me, whenever I connect it without the compass, for me, It looks kind of pillowy, so I'm just going to actually use my compass to help me. Now I'm going to go all the way around. Okay, and there you go. Okay, then I'm going to do the next one here. Okay, so x squared plus y minus 4 squared. So center here is at 0, 4, right? X minus h, since there isn't, it's 0. And then y minus k, so k is 4. This 16 is r squared. Okay, so if 16 is r squared, that means square root of 16. 4 is my radius. Okay. So I'm going to graph 0, 4 as my center. Okay, then 1, 2, 3, 4 across. 1, 2, 3, 4 up. 1, 2, 3, 4 down. 1, 2, 3, 4 left. Okay. Then you just connect it into a circle. Like I said, for me, never looks good without my compass, so I'm going to use the compass to help me. This compass isn't very good. So I'm going to be a little bit more careful as I do it. Okay. So I got it. Ooh, it's not tight enough. Okay. Then, wait. Okay. And then I'm going to connect. Alright, so if your compass is a little wobbly like mine is right now, that's okay. That's why I'm looking for those 4 dots. Okay, because as you can see, it kind of went out a little. Okay? So that's why I'm looking for those 4 dots. Okay. So next one here. So write the equation of a circle with diameter. So keyword here is that diameter. So these points are the diameter. Okay. So if I found the distance, it'd be the distance of the diameter. Okay, so I'm going to first find how long it is, the diameter, so that way I can get the radius. So diameter, distance here is, I'm going to do x minus x, so negative 8 minus 0 squared, okay, plus, okay, 2 minus 8 squared. Okay. If you did 0 minus the negative 8 or 8 minus the 2, that's fine. Once we square it, you'll get the same thing as me. Okay. So negative 8 minus 0 is negative 8. 2 minus 8 is negative 6. Okay. They should be in parentheses, because without the parentheses, it means something different. So negative 8 squared with the parentheses is positive 64. Negative 6 squared with the parentheses is positive 36. 64 plus 36 is 100. And square root of 100 is 10. So my diameter is 10. The radius then would be half of that, so it'd be 5. Okay. Then, since this is the diameter, the center should be in the middle. So how I can find the center, which is in the middle, is I'm going to add the two x's, 0 plus the negative 8, and find the middle, okay, by dividing by 2. Same thing with the y's. I'm going to add it, 8 plus 2, and divide it by 2 to find the middle. Okay. 0 plus negative 8 is negative 8, so negative 8 over 2. 8 plus 2 is 10, 10 over 2. Negative 8 over 2 is negative 4. 10 divided by 2 is 5. So that's my center. Here's my h and k. I'm writing the equation. So x minus h, so x minus negative 4 square, plus y minus k is 5 square, equals my radius, which is 5 squared. Okay, simplify. Minus a negative is plus, so x plus 4 squared plus y minus 5 squared equals 5 squared is 25. And there you go. Okay. Then I'm going to do the next one here. Okay, so again, write the equation of the circle. It is diameter that I'm given, AB. Okay, so when I find the distance for this, this is the distance for the diameter. Okay. So I'm going to do 5 minus negative 9. So 5 minus negative 9 squared. Sorry, should be 4. 5 minus negative 4. Let's change that. 4. Okay. Plus, then I'm going to do the y's. So 9 minus 6. 9 minus 6 squared. Okay. 5 minus negative 4 is 9, so this is 9 squared. 9 minus 6 is 3, so this is 3 squared. 9 squared is 81. 3 squared is 9, so then 81 plus 9 is 90. Simplify this. This would be 3 square root of 10 is my diameter. Okay. Which means my radius is half of that. So 3 square root of 10 over 2. Okay. You cannot simplify that square root of 10 and 2 because this is in a square root, this is not. Okay, so I'm going to leave it as is. Okay, it's a little ugly and messy, but that's okay. Then I just need to find the midpoint for this. Okay, so the center is in the middle of my diameter. So if these 2 points form my diameter when they're connected, the center is in the middle of them. Okay, so to find the middle, negative 4 plus 5, divide by 2. Okay, 6 plus 9, the y's, divide by 2. Negative 4 plus 5 is 1, so that's 1/2. 6 plus 9 is 15, so 15/2. Okay. And then if I change that 15/2, it'd be 7.5. Easier to graph if I were to graph it. Okay. So here's h, here's k. Now I'm going to plug it all in. So x minus 1/2 squared plus y minus k, which is 7.5 squared, equals, this is my radius, 3 square root of 10 over 2, and I'm squaring all of this. Okay. The reason why I put it in parentheses here is so that way you know the square goes to all of it and not just one part of it. Okay, so I'm going to simplify this. Okay, it's a little messy. Okay. Whenever we're raising something to a power, as long as there's no addition or subtraction in it, we can distribute it. Okay. So 3 square is 9. Square root of 10 and that square undo each other, leaving me with just the 10. And then 2 square is 4. Okay. Okay. This would be 90 over 4, which I'm going to simplify to 45/2. So this is pretty ugly, but this is my equation. Okay, so next one here, we are rewriting it in standard form, so we're going to be completing the square here. Okay, first thing I'm going to do is move my constants to the same side. So this minus 9 is going to move over by adding 9. So x squared plus y squared, this is gone, plus 14y, leave some space, 36 plus 9, 45. Then, this is the only x squared here. There's no x, so this is already in the squares completed. Okay. Then, I'm going to complete the square for this here, for the y's, y squared and 14y. So here I'm going to take the b, which is 14, divide it by 2 and square it. 14 divided by 2 is 7. 7 squared is 49. I'm going to take that 49, I'm going to add it to both sides. Okay. So this gives me x squared plus y squared plus 14y plus 49 equals 45 plus 49 is 94. Okay. Then, the x squared is already done. I'm going to factor this. This would be y plus 7 squared. 7 squared is 49. 7 plus 7 is that 14. Let's see here. Equals 94. Okay. This is my equation. My center would be at 0, negative 7, right? H, x minus 0, so that's why it's x squared. And then y minus negative 7, so. And then radius, again, this is r squared, so radius would be square root of that, square root of 94. 94 here, square root of 94 is already simplified radical, so there you go. Now I'm going to do the next one. Okay. It's a little close together, so I'm going to do it in a different color. I'm going to do it in like a bluish here. Okay. So first thing, Okay. I would want all my constants to the other side. So this is y squared negative 6x, x squared 18y. Okay, all my constants are already on the other side. Okay. Then this one, oh man, they try to trick me, right? I'm going to put my x's together and my y's together. So x squared and then negative 6x. Okay, I'm going to group them. Then I'm going to put my y squares together. So y squared and then my 18y. Equals negative 12. Okay, if you're like, what did Miss Ng do? All I did is I took my x's, right, and put it together. And then I took my y's and I put it together. Okay? That way it makes it easier to find what b is and complete that square. And then my constants are already all on the same side. Okay? Then I'm going to take my b, which is negative 6 here. I'm going to divide it by 2, and I'm going to square it. Negative 6 divided by 2 is negative 3. Negative 3 squared is 9. So I'm going to take that 9, I'm going to add it here, and add it here. Okay, so I did it for the x's. Now I'm going to do the same thing for the y. So I'm going to take that 18, divide it by 2. I'm going to square it. 18 divided by 2 is 9. 9 squared is 81. I'm going to add that 81 on both sides. Add 81. Add 81. Okay. So I'm going to rewrite it. So x squared minus 6x plus 9 plus y squared plus 18y plus 81 equals, I'm going to add those together. Negative 12 plus 9 plus 81. This gives me 78. Okay. Then I'm going to factor it. Okay. So here this factored would be x minus 3 squared. Negative 3 times negative 3 is 9. Negative 3 plus negative 3 is negative 6. Okay. Then this one would be y plus 9 squared. 9 times 9 is 81. 9 plus 9 is 18. Okay. Equals, and then 78. Okay, so this is my equation of the circle. Center is at 3, negative 9. Okay. Radius, this is r squared, so radius would be square root of 78. Okay, it's already in simplified radical form, and I'm done. Okay, so that's 5C. Next is 5D. Okay. And so this is all of our constructions. Okay. Okay, so let's get started. So this one is an inscribed circle in a triangle. So I'm going to start by doing two angle bisectors. So here. Okay. Then from each intersection. I'm not going to explain, I'm just going to do it. You can pause the video, rewatch it, or rewatch the one on Schoology. I need to get a pencil. So again, there's a lot of marks. Gets a little confusing sometimes, so I like to mark it in a different color. Just make sure that it's as accurate as possible. With the highlighter, it gets a little fat sometimes. In my opinion, the inscribed circle one is the hardest. This one, sometimes it's really hard to be accurate, right? So that's okay. I'm just really looking for those marks. I will be measuring it, okay? And yeah, it mostly, especially for the one that's the right triangle, that one is the hardest one to be accurate for some reason. So the two angle bisectors, I've cut these angles in half. This gives me my center. Okay. And then this last step is the one that I feel like everyone keeps forgetting. Okay, so from the center, you're going to make sure it crosses your thing twice. Here, and do it here. Oh, I don't know. I feel like my compass moved. Okay. And connect from here to here. Okay. And do blue. Okay. As you can see, it's not actually that orange line, it's slightly away from it. Okay. And then this, let's see how accurate I was. Let's see if my compass actually moved. Oh, pretty good. Pretty good. And there is my inscribed circle. So what I did is I measured from here to here, from where it touches, and then I did it. Oh, sorry, I should. Okay. So now I'm gonna ink in my inscribed circle. Okay. You don't have to ink it in for me. It's fine. I can see it. Okay. Oh, see, because when you ink it in, it doesn't look very accurate sometimes. Yeah, so for you guys, maybe it's better not to ink it in, because then I might think that. See, like I missed it. It should be here. That's where the line is. Okay. So I'm going to do it again. Inscribed circle. So it's going to start with 2 angle bisectors. So bisect the angle. Okay. I'm going to ink it in. Again, you don't have to ink it in. Sometimes inking it in is not good, at least if you use highlighter, because it gets a little thick. And then for some of us, we are like way beyond, like not even accurate when we do that. Okay. So I ink it in, that way you guys can see it better. Okay. Next, I'm going to do this one here. No, I'm actually going to do this one here. Ooh, see, moved a little. So every time our compass moves a little, right, we're slightly less accurate now because it moved, right? Okay. I feel like constructions are always hard to do under the camera as well. Okay. Mostly because I'm so focused on it, I'm like not even paying attention if it's on the camera. Okay. Which is why I posted the link on Schoology, because they do it digitally, which is why theirs construction is perfect, right? Because there's no human error for that. Right? They're doing it on the computer with a perfect compass that can make perfect circles. Right? And so this is just kind of like a review of it, a quick one. It's not completely accurate. Okay, so this is my center of my circle. Then I need to figure out my radius of my circle. Okay, so using that center here, need to make sure it crosses this twice. So I'm going to do once here. Okay. Alright, so make sure you're on this one and not the pink one. Okay, there we go. And blue. Okay. But in my opinion, this is definitely the hardest one. Oh, how accurate is it? Okay. Okay. And so now, let's see. Okay, so this allows me to measure how big the radius is. Right on top of it, as close as possible. So slightly out, but pretty good overall. Oh, you can't even see it. Okay, so I measured up to where the blue touches that, and I went all the way around. So this one's pretty good, just slightly out, right, due to maybe compass moving or so for you, it's probably best your final one, don't ink it in, right? You want it to make it easy for me to see it, right? Easy to grade it to make sure it's correct, right? But not where I think, oh, did you even use a compass with it? Okay, so that's inscribed circle and a triangle. Okay, the next one is circumscribed circle around a triangle. This one, instead of angle bisectors, okay, we're doing perpendicular bisectors. We're bisecting that segment. Okay, so you pick a side, open your compass slightly more than half, above and below. Go to the other side of it, above and below, and then you're going to connect. I'm going to ink it in, that way you guys can see it. Maybe I should move my camera over. Okay, there you go. I really like constructions, just because I think it's therapeutic, soothing. Drawing circles, drawing arcs everywhere, color coding it. I know some of you guys don't because of the memorization that's required. Okay, there you go. So one perpendicular bisector. Time to make another one, so pick another side. Okay. And go same thing, a little more than half. Well, just needs to be more than half, above and below. Okay. Gonna go on the other side. Here. Ooh, above and below, barely made it. Okay. And connect. Okay. This gives me the center of my circle. So that's right here. Okay. And this one is a circumscribed circle. It's around the triangle. Okay. So from here, pointy part at the center of the circle, you measure to one of your vertices. Doesn't matter which one, they should be equidistant now. Okay. And you're going to go around. Whee! Look at that. Looks good. I'm not going to ink it in. But there you go. Okay. So I'm going to do one more here of the circumscribed circle around the triangle. So again, perpendicular bisector, you're going to open slightly more than half. So I'm going to do this side first. So slightly more than half. Arc above and below. Right. Go to the other side. Not your above, below. Okay. Ink it in. Again, you don't have to ink it in. Okay. I'm just doing it so that way it's easier for you to see. Okay. Connect. Helps me to find the center of my circle that I'm going to draw. Okay, so I did one side. Now I'm going to do the other side. Doesn't matter which side you do. So I'm going to choose this one here. Okay, so open slightly more than half. Arc above and below. Go to the other side. Arc above and below. Okay. Here. Note that I'm just highlighting the important parts so that way you can see it. Ooh. Okay. So the center of my circle is right here, actually. Kind of looks either on that line or slightly above it. Okay. From here, measure to any of your vertices. It should be equidistant here because we're doing a round and it should touch each of them. And then we're swinging. Oop, looks pretty good. Barely made that one. Oop, and there you go. And there's my circumscribed circle. Sorry, it's kind of showing the other side, but here it's this one. Okay. Next one. So equilateral triangle inscribed in a circle. Love this one. This one's the easiest. Okay, pick a point on your circle. Doesn't matter where. Okay. Measure from that point to the center. Then you're going to go around, make a mark. Then go from that intersection of your circle, make a mark. Then go from that intersection of your circle, make a mark. Then go from that intersection of your circle, make a mark. And go from that intersection of the circle, make a mark, and then if you made another mark, you'd be right where you started. So I have it all the way around. Okay, and then for the triangle one, okay, you are just going to connect every other. So I have my dot. I'm going to skip this one. I'm going to connect it to the next one. Okay, then I'm going to skip it and then do the next one. And then I'm going to skip it and do the next one. And there you go. And this is my equilateral triangle. It is equal lengths on each side. Okay. Then I'm going to do the next one. Okay. I tend to do it here. Okay. You can do it anywhere, really. It doesn't matter. So let's say I put it right underneath it. That's fine. Okay. It just means my circle might be a little rotated. Doesn't matter. Okay. Measure to the center. Okay. Then I'm going to make a mark. Go to that intersection. Make a mark, go to that intersection, make a mark, go to that intersection, make a mark, go to that intersection, make a mark. Next one I should be back at where I started. Okay. Then you're going to skip one, connect the next one. Skip one, connect. Skip one, connect. And there you go. Okay. Next one here is a square. Okay. How it starts with our square is first we draw a diameter. So diameter, again, definition should go through our center. Okay. And then what we're going to do is we're going to do a perpendicular bisector for this. So we're going to open slightly more than half. Okay, some of you guys are doing it and it's right, like, it's not looking good. Okay, so it should be slightly more than half. Okay. I'm going to do it more. Okay. So above and below. I'm doing it bigger so that way it's outside of the circle. That way because some of you guys, when you do it, it's right on here. Okay, and when it's right on here, it doesn't look as good. It's hard to see if you even did it correctly. So I'm doing it a lot bigger, so that way it ends up being outside of the circle. If yours is inside, that's good. I just don't like it when it's right on your circle. It makes it really hard to see. Okay. Then I'm going to connect here. Should be going through your center as well. Okay. And then, so let me highlight it. Okay. Please make sure you use a ruler. Some of you guys didn't use a ruler, right? So it doesn't look good, right? And then all I have to do is connect where each of these touch the circle. They should look like 90-degree angles, okay, because it's a square, okay, and all side lengths should be the same, okay, and there, my square looks good, okay. Okay, so same thing, I'm going to do it again. So constructing a square inside a circle, okay, first you draw a diameter. I'm doing it this way this time. Okay. Then I'm going to do a perpendicular bisector, so from here, I'm going to open it more than half. Okay, I try to do it a little bigger so it ends out outside the circle. But if yours is inside the circle or on the circle, that's okay. Right? That's fine. I'm just making it so that way it's clear to you guys and you don't see. It doesn't like make it hard to figure out how I got this. Okay. And then I'm going to connect. Okay. If you did it correctly, it should go through your center. Let me ink it in for you. Connect. Go. And then let's connect. So where it touches the circle, so here to here. Here to here. Here to here. And here to here. And it's a square. It's just a little rotated, right? So here's my square. Right, if I put it this way, you can clearly see it's a square. Okay. So that's my square. Next one is a hexagon. Hexagon one is similar to the triangle. So for that one, instead of connecting every other, you're going to connect all of them. So starts off, draw a point somewhere on your circle. Okay. Use your compass to measure the radius so from that point to the center. Do a mark. Go to the intersection, 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 do a mark. Okay, it should be all the way around. Oh, can't see it. Okay. And once you have them all the way around, then you're going to connect each of them. So here to here. Here to here. Here to here. Here to here. And here's my hexagon. Looks good. All sides should be the same length. Okay. Doing it one more time here. Okay, so pick a point on your circle, doesn't matter where. Okay. Use your compass to measure the radius. So pointy part here, center here. Okay. And I'm going all the way around. So intersection, go to the intersection, make a mark, go to the intersection, make a mark, go to the intersection, make a mark, go to the intersection. Oh, it's off the camera now. Make a mark, should have marks all the way around. Okay. Once you have that, you're just connecting each intersection. So here. Storm. And there you go. Okay. Okay, last couple ones before we finish our constructions. So this one is tangent at a point on the circle. Okay. So first thing you're going to do is you're going to connect your center to that point that you want your tangent line to go through. Okay. So connect. Okay. Then, from there, that point, you're going to open your compass so that it crosses that line twice. Any length will do. Okay. Then, you're going to open your compass bigger. And you're going to go from those intersections you now made. You're going to make an arc. Go to the other side. Make an arc. And then, all you have to do is connect that with your tangent point. And there you go. That's it. The next one here I'm going to do in a different color. So I'm going to do this one in pink. So first thing you're going to do is connect your center to that tangent point of tangency. Okay. Then you're going to open your compass. Any length will do. You're going to cross it twice. Once. Turn it twice. Okay. Cross it twice. I'm going to open it slightly bigger. And then go from there. Intersection, make an arc. Go to the other section, make an arc. And then I'm going to connect that point of tangency to the intersection. And there you go. Okay, so that's for the point tangent at a point on the circle. Okay. Next one here is when it's not at that point. Okay. So what you're going to do then is here, you're just going to connect that point to that tangent point. Okay, you don't need to go beyond it. Okay. Then here, you're going to do a perpendicular bisector. You're going to open slightly more than half, above and below. Go to the other side, above and below. You're going to connect it. This is your perpendicular bisector of that segment. Then what you're going to do is from where those two lines intersect, or those two segments, you're going to measure that intersection, how far it is from your center. And then you're going to swing it around once, twice to where it touches the circle. Okay. And that, then you connect your outside point, your external point, to that intersection. Okay. And there are your two tangent lines. I'm going to do it one more time here. Starts, going to connect. Going to find the perpendicular bisector, so slightly more than half. Do an intersection above and below. Go on the other side. Make my, oh, it's right on that circle. Above and below. Connect. Okay, I'm going to highlight it so that way you can see it better. Okay, it's not on the circle, it's slightly above it. Okay, then measuring where that intersection of that perpendicular bisector is to the center. And then I'm going to cross my circle. Okay, it's right above where I did it before. Okay, that's not good. Okay, so let me highlight it for you. So when I did that, it was this and this. Okay. And so it's right here where it touches the circle and right here where it touches the circle. Okay. Sorry, it's so close to the orange, it's a little hard to see. Then I just need to connect. Okay. One thing I could have done to fix this, right? Ooh, that was not straight. Okay. Is probably to make it a little bit bigger for when I did my orange arcs. Okay. So there you go. Okay, so that's 5D. Last section, 5E. Thank you for hanging in there. Okay. So last section, 5E, is on arcs, sectors, and radians. We got a while to go. Okay, so let's do arc length. Okay, so arc length. Okay. So formula, length of arc equals measure of arc over 360. This tells us how much of the circle it is. Okay. And since this is related to circumference, we're going to use the circumference formula. Okay. So this is the circumference. Okay. Okay, so here I want the length of AB. Okay, so that length will equal, okay, this is 30 degrees here, so that means this is 30 out of the total 360 times 2 pi. Radius here is 2, right? Center to point on circle, so that's 2. And then I just need to solve it. So 30 over 360 here is 1 over 12. So 1 over 12. 2 times 2 is 4. So 4 pi. This is 4 pi over 12. 4 over 12 is just 1, so pi over, 4 over 12 is 1/3, so pi over 3. Okay, and then this is units. Okay. It asked me to round to the thousands, so really if you're like, I don't know how you even got, you could literally just enter this in and then give me rounded to the nearest thousands. Okay. So pi divided by 3. Okay, so this is approximately 1.047 units long. Okay, that's the approximate length. Okay. So next one here is length of CD. Okay. So the length of it equals, this is 120 degrees out of the total 360, so 120 out of 360 times 2 pi. Radius in this case is 6, so 2 pi 6. This is 1/3, 120 over 360. 2 times 6 is 12, so 12 pi. Okay. This is 12 pi over 3. 12 over 3 is 4, so 4 pi units. Okay. I want the answer in thousands, so you're going to type it into your calculator and round for me. This is approximately 12.566 units. Okay. There you go. Okay. Next one here. This time I want the circumference. Okay, so circumference is really this part here. So instead of solving for this, I'm solving for this now. Okay. It gave me the length. So length 6.806 kilometers equals, this is 78 out of the total 360 of the whole circumference. Okay. So how I'm going to get rid of it is I'm going to do the opposite. So since this is times 78, I'm going to divide by 78. Since this is divide by 360, I'm going to times 360. Okay. I'm not going to simplify the fraction. I'm just going to enter it in the calculator. Okay. This is circumference. So I'm going to do 360 times this. So 360 times 6.806. Okay. And then I'm going to divide by 78. And this gives me approximately 3 decimals. So 31.412, and it's in kilometers, so kilometers. So next one, same thing. I want the circumference of the whole circle. Okay. So the length of EG I already know is 23.562 miles. Okay. This is 135 degrees out of the total 360 of the circle. Okay. And then since I want circumference, I'm going to leave it as all of circumference rather than 2 pi r. Okay. And same thing. Going to get rid of the times 135 by dividing by 135. Going to get rid of the divide by 360 by timesing 360. What you do to one side, you need to do to the other. Okay. This leaves me with C because they cancel. Okay, and I'm going to type this into my calculator. So 360 times 23.562. Then I'm going to divide by 135. And this gives me 62.832. Don't forget the units here. That's in miles. So here's my miles. There you go. Okay. Flip. Okay. This time, though, I want to find the radius. Okay, so I'm going to leave it as 2 pi r instead of just using circumference. Okay. So here, the length is 10/3 pi kilometers, so 10, I'm going to put the pi up here, 3 kilometers, equals, this is 20 out of the total 360 times 2 pi r. Okay, I'm leaving it as 2 pi r instead of circumference because I actually want to find the radius this time. Okay, so I'm going to simplify it. 20 over 360 is 1/18, both divisible by 20, times 2 pi r. The 2 over 18 simplifies to 1/9. So really, this is 10 pi over 3 equals pi over 9, and then times our radius. Okay, so this is times pi divided by 9, so opposite would be divide by pi and multiply by 9. So that's what I'm going to do, pi 9. Okay. So pi and pi cancel, 9 and 9 cancel here, so the radius, 9 divided by 3 is 3, so 3 over 1. The pi and the pi undo each other, right? Times pi divided by pi. So this is just 3 times 10. This is 30. And then, oh, I kept forgetting my kilometers. And then kilometers. So 30 kilometers is my radius. Okay. So next one here, length of EG. Okay. So length is 6 pi. This is 90 degrees, right angle, over 360 times 2 pi r. Okay. 90 over 360 is 1/4, so 1/4 times 2 pi r. Okay. The 2/4 simplifies to 1/2. Okay. So this here is pi half r. So this is pi times r, so opposite is to divide by pi. This is divide by 2, opposite is to times 2. So times 2 over pi. Okay. So here the pi times pi, divide by pi cancel to be 1. Divide 2 times 2 cancel to be 1. 1 times anything is itself, so that's why it's just 1 times r, which is r. Pi and pi undo each other. 2 times 6 is 12. And then I forgot my kilometers. It is 12 kilometers. There you go. So next one is same thing, except now we're doing area. Okay, so this is area of the sector. I just want the smaller sector. Okay. So here, area of sector formula. Similar, instead of circumference though. Right, so measure of arc over 360, that tells us how much of the circle it is. And then times, area formula is pi r squared. Okay, so here we go. Okay, so I want the smaller sector, right? Remember to read the directions. So this one I want the smaller sector. So here, the larger part is 272 degrees. So if I do 360 minus 272, it tells me that this is 88 degrees. Okay, so here, area of sector, arc is 88, so 88 over the 360 times pi. Radius is 18, so 18 squared. Oh, sorry, I should write it down. 18 squared. Okay, so here, since I just want it to nearest thousandths, right? I'm just going to type it all into the calculator. I'm going to do step by step. Okay, 88 over 360 times pi. 18 squared is 324. Okay, so I'm going to multiply it together. So 88 over 360 times 324 pi. This gives me approximately 248.814. There's no units, so units and squared. Okay. So next one here, again, smaller sector. So this is definitely the smaller sector. It's 10 degrees. So 10 out of the 360 times pi. Radius is 13 and then square. Okay, this is 1 over 36 if I simplified it. 13 square is 169. Okay, I'm just going to multiply it now. So 169 pi times 1 over 36. And then this gives me approximately 14.748. There's no units specified, so it's just units. And then area is units squared. Okay. So next one here, this time, instead of us finding the area of the sector, we're given it. Oh, I should have a square here. I should have an inch square. Okay. And then we are finding the area of the whole thing, right? So this is area of the whole thing. So instead of putting pi r square, I'm just going to put a big A for the circle. Okay. So area of the sector, okay, 2.793 equals, it is 80 out of the total 360, and then times A. So doing the opposite, this is times 80 divided by 360. Opposite would be divide 80 and times 360. So that's what I'm going to do, divide 80 times 360. Cancels. So area equals, okay, 360 times 2.793 divided by 80. This gives me 12.56. It was 8.5, right? But we'll do 12.569, and then this is yards squared, approximately. Okay. Then here's the next one. So area of the sector, 30.543 inches squared, equals, this is 140 out of the total 360. Okay, I want area of the whole circle, so I'm going to leave it as area of the whole circle. Opposite of times 140 is divide by 140. Opposite of divide by 360 is times 360. Okay. This is area. I'm going to multiply it. So 360 times 30.543 divided by 140. So this is approximately 78.539 units is inches, so inches square for area. And there we go. Okay. Bottom part here. This time I want radius. Okay, so I'm going to leave it as that pi r square instead of doing the A that I did up here. Okay. So area of the sector is 75 pi. 120 out of the total 360. Times 2 pi, times pi r square. Okay, so we're going to have to be square rooting some stuff. Okay, I'm going to simplify that 120 over 360. Okay, this is 1/3, so pi thirds, and then r square. So opposite of this is times 3 and divide by pi. So that's what I'm going to do. Times 3 and divide by pi. Okay. This leaves me with r squares, because times 3 divided by 3 cancel each other. Times pi divided by pi cancel each other. Okay. Same thing here, pi, pi. So 75 times 3 is 225. I'm going to get rid of the square by square rooting. Okay, so that's why now, originally it was feet square. I'm square rooting it to get rid of it just to be feet. So square root of 225 is 15. Okay. So it was in feet, so 15 feet is my radius. Okay. Next one here. Okay. Area of the sector is 13.5 pi centimeters squared. Okay. This is 60 out of the total 360 times pi r squared. I'm going to simplify this. Okay, 60 over 360 is 1/6, so pi 6 and then r squared. Going to get rid of this by timesing 6 and dividing by pi. So timesing 6 and dividing by pi. This leaves me with r squared. Pi and pi cancel. So 6 times 13.5 is 81. So 81 centimeters squared. Getting rid of the square by square rooting. That leaves me with r here. Square root of 81 is 9. Square root of centimeters squared is just centimeters. So radius is 9 centimeters. Okay. And there you go. Last section is radians to degrees. Zoom out here. Okay, so here, to convert degrees to radians. Okay, so degrees to radians, I'm going to multiply by pi over 180. Okay. So nice and easy. So negative 350 here times pi divided by 180. So this is negative 350 pi over 180. Okay. Both of them are divisible by 10. So this becomes negative 35 pi over 18. Next one here. 20 degrees, change it into radians, pi over 180 degrees. Okay. This is 20 pi over 180. Both numbers divisible by 20, so 20 divided by 20 is 1, so 1 pi. 180 divided by 20, is 9. So this is pi over 9. Okay, that was messy. Let me write it again. Pi over 9. Okay. 200 degrees times pi divided by 180. 200 pi over 180. Okay, both divisible by 20, so this is 10 pi. 180 divided by 20 is 9, so 10 pi 9. That's the radian. Okay. So this one, same thing, change it to radians. So this one cancels out, leaving me with just pi. Okay. Again, same thing, times pi over 180. This is negative 285 pi over 180. For sure, since they both end in 5 and 0, divisible by 5. So this is 57 pi. 180 divided by 5 is 36. They're also both divisible by 3, so I'm going to divide by 3. 57 divided by 3 is 19. 36 divided by 3 is 12. So next one. Okay. Last one here. Times pi over 180. This is 50 pi over 180. Both divisible by 10. So 5 pi over 18. And there you go. Okay. Next one down here. Should have left more space. Okay, so to go opposite from radians to degrees, we're going to do the opposite. Instead of pi over 180, it'll be 180 over pi. Okay. So here, to convert, I'm going to times 180 over pi. Pi's cancel out. 18 and 180, once, this is tenths, so this is 170 degrees. Here, times 180 divided by pi, pi's cancel, is 180 divisible by 12. Yes, it is. So this is once, this goes into it 15 times. 13 times 15, 195, so negative 195 degrees. Okay. Next one here, times 180 over pi. 6 goes into 6 once. 6 goes into 180 30 times. Okay. Then multiply across. Oh, pi and pi cancel. 11 times 30 is 330 degrees. Okay. Next one here, times 180 over pi. Pi's cancel out. 9 goes into 9 once. 9 goes into 180 20 times. Negative 2 times 20 is negative 40, so negative 40 degrees. Okay. Times pi, or times 180 over pi. Pi's cancel out. 12 goes into 12 once. 12 goes into 180 15 times. 15 times 5, 75, so 75 degrees. Times 180 over pi. Pi and pi cancel out. 2 and 180, 2 goes into 2 once. 180 goes in, 2 goes into 180 90 times. 3 times 90 is 270, so negative 270 degrees. And there you go. That's it. That was a lot. We are done. Best of luck on the test. Have a great rest of the day. Bye, guys.